your quiz on 13.1 to 13.2 literally goes over everything from 13.1 and 13.2. You can use a calculator on your quiz tomorrow, so please make sure you bring your calculator with you. Okay. The first question, getting right into this, tells you to write the first 5 terms of the sequence. Assume n begins with 1. So for these, it says a n. It should be a sub n. Just take it as a sub n, please. For number 1, you should have a sub n is equal to 8n plus 6. So to find your first term, you're going to have 8 times 1 plus 6. That's going to give you 8 plus 6, which is 14. For your second term, a sub 2, you're going to have 8 times 2 plus 6. So that's going to give you 16 plus 6, which is 22. For your third term, a sub 3, you're going to have 8 times 3 plus 6. That's going to give you 24 plus 6, which is 30. Next, for your fourth term, you have a sub 4. It's going to be 8 times 4 plus 6. That's going to give you 32 plus 6, which is 38. And then for your fifth term, a sub 5 is equal to 8 times 5 plus 6, which is 40 plus 6, and that is 46. So the first 5 terms of your sequence here are the 14, 22, 30, 38, and 46. For number 2, you're finding the first 5 terms in a sub n is equal to 3n over n squared minus 2. So the first one we're going to do is the first term. So that's going to give us 3 times 1 over 1 squared minus 2. That's going to simplify to be 3 over 1 minus 2, which is 3 over negative 1. And that's going to be negative 3 for your first term. For your second term, you're going to find 3 times 2 over 2 squared minus 2. That's going to give you 6 over 4 minus 2, which is 6 over 2, and that's 3. For your third term, you're doing 3 times 3 over 3 squared minus 2. That's going to give you 9 over 9 minus 2, which is 9 over 7. That does not simplify any further, so leave it 9/7. Next, for your fourth term, you're going to have 3 times 4 over 4 squared minus 2. The 3 times 4 is 12. Your 4 squared is 16. Minus 2 gives you 12 over 14, which simplifies to give you 6/7. Then for your fifth term, you're going to have 5 times 3 over 5 squared minus 2, which is 15 over 25 minus 2, which gives you 15 over 23. So the 5 terms that you have in your sequence that you're looking for are the negative 3, 3, 9/7, 6/7, and 15 over 23. Your next section tells you to find the indicated term of the sequence. For number 3, you're given that a sub n is equal to n squared over 4n minus 3. You're finding the 16th term. So to find a sub 16, we're going to have 16 squared over 4 times 16 minus 3. That 16 squared is 256. The 4 times 16 gives us 64 minus 3. So that's 256 over 61. For number 4, you're given that a sub n is equal to negative 1 to the power of n minus 1 times n times n plus 1. You're finding the 19th term. So to find a sub 19, we're going to have negative 1 to the power of 19 minus 1 times 19 times 19 plus 1. So that's going to give us negative 1 to the power of 18 times 19 times 20. So this is going to simplify to give us 1 times 380, which is just 380. Everything that we've looked at so far, numbers 1, 2, 3, and 4, do come from 13.1. So the next section that we're going to look at is coming from 13.2. For number 5 and 6, it tells you to write the expression for the apparent the nth term of the sequence. You're going to assume n begins with 1, and then you're going to find a sub 570. So you're going to find the 570th term after you find the rule. With this, we're going to use the formula a sub n is equal to a sub 1 plus n minus 1 times d. So the first thing we have to do is find our common difference. So we're going to be either adding or subtracting something, and that is what d is going to equal. So if we look at 5, the numbers that they give us are negative 3, negative 8, negative 13, negative 18. From negative 3 to negative 8, you are subtracting 5. From negative 8 to negative 13, you're subtracting 5. From negative 13 to negative 18, you subtract 5. So for this one, d is equal to negative 5. Your a sub 1, or your first term, is negative 3. And n is going to stay n until you plug in the 570. So to first find your rule, you're going to have a sub n is equal to negative 3 plus n minus 1 times d, which is negative 5. Distribute your negative 5 in, and that's going to give you a sub n is equal to negative 3 plus negative 5n plus 5. So if you simplify this, you're having a sub n is equal to negative 5n plus 2. So that is your rule to find the nth term. If we are to find the 570th term, you're going to have a sub 570 is equal to negative 5 times 570 plus 2. Your negative 5 times 570 is negative 2,850 plus 2 gives you a negative 2,848. For your next question, you're given the numbers negative 1/2, 1, 5 over 2, and 4. If you are adding 3/2 to these, or 1 and 1/2, you are getting each of these numbers. So in this case, d is equal to 3/2, or 1 and 1/2. Your a sub 1 is going to be negative 1/2, and your n at one point is going to be the 570. First, find your rule. So you're going to have a sub n is equal to negative 1/2 plus n minus 1 times 3/2. If you distribute your 3/2 in, that's going to give you a sub n is equal to negative 1/2 plus 3/2 n minus 3/2. If you combine like terms, you're left with a sub n is equal to 3/2 n minus 4 over 2, which is just 2. Next, find your 570th term. So this is your rule. Next, you're finding a sub 570. So that's going to give you 3 over 2 times 570 over 1 minus 2. 2 goes into 570 285 times. So multiply that by 3. You're left with 855 minus 2, which gives you a sub 570 is equal to 853. Your next questions tell you to find the sum. For number 7 and 8, you are going to make sure you use your formula, which is the S sub n is equal to n over 2 times a sub 1 plus a sub n. To find n, remember it is top minus bottom minus 1. So for 7, you're starting at 4, going to 27, using the rule 8i minus 5. So first find n, and it's going to be 27 minus 4 plus 1, which gives us 23 plus 1, and that's 24. So n is 24. Next thing you have to find is a sub 1. A sub 1 is found by taking that 4 and plugging it in for I. So that's going to be 8 times 4 minus 5. That gives you 32 minus 5, which means a sub 1 is 27. Now you need to find a sub n. A sub n is going to be found by taking n, which is 24, and plugging that in. So it's going to be 8 times 24 minus 5. The 8 times 24 gives us 192 minus 5 gives us a sub n is equal to 187. So now take these three terms, the n is equal to 24, the a sub 1 is equal to 27, and the a sub n is equal to 187, and plug them into the formula. You're going to have s sub n is equal to n, which is 24, over 2, times a sub 1, which is 27, plus a sub n, which is 187. Your 24 divided by 2 gives you 12. The 27 plus 187 is 214. So if we multiply these, we get a sum of 2,568. This should be plus 1, sorry. That top one should be plus 1. For 8, you're finding the sum with starting at 3, going to 9, and your rule is the 1/3 times j. So first find n. To find n, we're going to do top minus bottom plus 1. So it's going to give us 6 plus 1, which means n is 7. To find a sub 1, we're going to take the 3, plug the 3 in. So that's 1/3 times 3, which gives us 3 over 3. And that a sub 1 is just 1. Next, you're finding a sub n. So take the 7, plug it in. That's 1/3 times 7, which means a sub n is equal to 7/3. Use your n, a sub 1, and a sub n. Plug them into that s sub n is equal to n over 2 times a sub 1 plus a sub n. This is going to give you s sub n is equal to 7 over 2 times 1 or 3 over 3 plus a sub n, which is 7 over 3, which simplifies to give us a sub n is equal to 7 over 2 times 10 over 3, which simplifies to give us s sub n is equal to 70 over 6. They're both even numbers, so simplify it further, and that's 35 over 3. For number 9, you're finding the common difference given the arithmetic sequence. So you are given the numbers 742, 749, 756, and 763. From the 742 to 749, we are adding 7. From 749 to 756, we add 7. From 756 to 763, we add 7. So your D, or your common difference, is just 7. To find the nth term, given that D is equal to 7, you can find that using that formula that is the a sub n is equal to a sub 1 plus n minus 1 times d. So keep that in mind too. So if it asks you to find the common difference and then find a certain term, you would use that a sub n is equal to a sub 1 plus n minus 1 times d. For number 10, we are writing the first 5 terms of the arithmetic sequence, given the first term is 19 and your common difference is -4. So to find the second term, since we already have the first term, we're going to do 19 plus 2 minus 1 times -4. That's going to give us 19 plus 1 times -4. So 19 minus 4 gives us our second term of 15. You can also just take the 19 and subtract 4 from it, and you get 15. Which means for a sub 3, you can just subtract 3 from 15, or sorry, 4 from 15, and you get 11. A sub 4 would be 11 minus 4. That's giving you 7. And then a sub 5 would be 7 minus 4, which is 3. So the first 5 terms of your sequence are 19, 15, 11, 7, and 3. For number 11, it tells you to use the formula for the general term or the nth term of the arithmetic sequence to find the indicated term of the sequence with the given first term a sub 1 and the common difference d. So you're finding the 80th term when your first term is -5 and d is -6. Use your formula that we were talking about, that a sub n is equal to a sub 1 plus n minus 1 times d. So you're finding the 80th term, so that means you're going to have a sub 80 is equal to a sub 1, which we said is -5, times n, which is 80, minus 1 times d, which is -6. So that 80 minus 1 is 79, times -6. This is 5 plus, -5 plus, sorry guys. So this is going to give you the 79 times -6, which is -474. So it's -5 plus -474, which gives you a sub 80 is equal to -479. For number 12, you're finding the formula for the general term or the nth term of the arithmetic sequence. From there, you are using that formula to find a sub 20, which is the 20th term of the sequence. So to first find this formula, you have to find d. So from 10 to 1, we subtract 9. From 9 to -8, or sorry, 1 to -8, we subtract 9. From -8 to -19, we subtract 9. So that means d is equal to -9. You need a sub 1, which is 10. And you're going to plug this into that a sub n is equal to a sub 1 plus n minus 1 times d, which is right above this. So that means you're going to have a sub n is equal to a sub 1, which is 10, plus n minus 1 times d, which is -9. Distribute your -9 in. That's a sub n is equal to 10 minus 9n plus 9, which then simplifies to give you a sub n is equal to -9 n plus 19. So that's your formula. From here, use that formula and find the 20th term. So you're finding a sub 20. That means you're going to have -9 times 20, plus 19. That negative 9 times 20 is negative 180. If you add 19 to that, it's going to give you a negative 161 for your 20th term. For number 13, it tells you to find the sum of the first 30 terms of the arithmetic sequence 6, 16, 26, 36. First off, what's the common difference? What's happening between these terms? You're adding 10, right? So D is 10. With that, it tells you to find what? Not the first 30, but the sum of the first 30. So when we're working with the sum, we're using the formula S sub n is equal to n over 2 times a sub 1 plus a sub n. Okay. Your first term is what? 6. So that's a sub n. You have a sub n. We don't need that. Your n, however, though, your a sub 1 is 6. Your n, however, to find n, we said top minus bottom plus 1. If you wrote this out as the sum, you're starting with n equaling what? And then your ending term is 30. So if that's the case, find your n. So let's use that as the first term, a sub 1. So do the 30 minus 6 plus 1. So that's 24 plus 1, which is 25. So if we plug that in, you're going to have 25 over 2 times a sub 1, which we said is 6, plus a sub n, which is what? So to find your 30th term, to get that a sub n, you can't use what you have here. You have to use the formula that we used in the two questions before this, that a sub n is equal to a sub 1 plus n minus 1 times d. We said your common difference, d, is 10. So find that first. So that means you're finding a sub 30 is equal to, we said a sub 1 is 6 plus 30 minus 1 times d. So that's 30 plus 29 times 10. So 6 plus 290 is 296. So that's the 296 inside there. So from here, simplify. Your 6 plus 296 gives us what? So multiply the 302 over 1 by 25 over 2. 2 goes into 302 how many times? 151. If you multiply the 151 by 25, you get 3,775. For 14, it tells you to find the first 3 terms and the last term of the arithmetic sequence. So the first 3 terms, you're going to start at 1, plugging those into that negative 3 times I. So 1 plug in, 2 plug in, 3 plug in, and then the last term would be the 60th term. So then plug in the 60. So to find the first term, you are going to find negative 3 times 1, which is negative 3. To find the second term, that's negative 3 times 2, which is negative 6. To find the third term, that's negative 3 times 3, which is negative 9. And to find the 60th term, you're going to have negative 3 times 60, which is negative 180. So your sequence should look like this: negative 3, negative 6, negative 9, comma, dot, 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 which means it continues all the way up to negative 180. For 15, it tells you to use the formula for the sum of the first n terms of the arithmetic sequence to find the indicated sum. So this one gives you I is equal to 6. You're going up to 387 with the rule 3i minus 6. So for this, the first thing you want to do is find n. So n is going to be the 387 minus 6 plus 1. Your 387 minus 6 gives us 381. If you add 1 to that, that means n is equal to 382. Plug this into your formula when you find a sub 1 and a sub n. To find a sub 1, we're going to have 3 times 6 minus 6, which is 18 minus 6, and that means that a sub 1 is 12. To find a sub n, which is 382, we're going to have 3 times 382 minus 6. Oops. The 382 times 3 gives us 1147. Minus 6 is 1140. So if we plug this into our formula that S sub n is equal to n over 2 times a sub 1 plus a sub n, we're going to have S sub n is equal to 382 divided by 2 times 12 plus 1140. Your 382 divided by 2 gives you 191. The 12 plus 1140 is 1152. If you multiply both of these together, you are left with 220,032. For your last two questions, it tells you to write the rule for the arithmetic sequence given the following information. For 16, you're given a sub n is equal to negative 24, and a sub 37 is equal to negative 99. You're then going to find a sub 1500. So you can write these as ordered pairs to then find your common difference by finding the slope. So if we were to do that, you would have 12, negative 24, and 37, negative 99. So to find our slope, we're going to go negative 99 minus negative 24 over 37 minus 12. Your negative 99 minus negative 24 is going to become plus 24. And that's going to give you a negative 75. And then your 37 minus 12 gives you 25. So if we divide these, we have a common difference, or D, of negative 3. To find your a sub 1500, you're going to do a sub n is equal to your a sub 1, which we need to find. So let's do that first. Let's find a sub 1. If we find a sub 1, we're going to use the first one that we have here. So that means we're going to have negative 24 is equal to a sub 1 plus the number that we have there, which is 12 minus 1 times our common difference, which is negative 3. So this is going to turn into negative 24 is equal to a sub 1 plus 11 times negative 3, which is negative 24, is equal to a sub 1 minus 33. We add the 33 over, and we're going to have an a sub 1 of 9. So now we can use that in our formula so that we have a sub 1500 is equal to a sub 1, which is 9, plus n, which is the 1500, minus 1, times our common difference, which is negative 3. So that's going to give us 9 plus 1499 times negative 3. The 1,499 times negative 3 gives us 9 plus negative 4,497. So then if we add the 9 to that number, we are left with a 1,500th term of negative 4,488. If we look at the next question that we have a sub 9 is equal to 118 and a sub 38 is equal to 524. First, we're going to find our common difference. So we're going to work with these 2 points, which are going to be 9, 118, and 38, 524. So find your slope. We'll do 524 minus 118 over 38 minus 9. So 524 minus 118 gives us 406 over 38 minus 9, which is 29. The 406 divided by 29 is 14, so your common difference, or D, is 14. From here, find a sub 1. I'm going to use the 9, 118, and it's going to give us 118 is equal to a sub 1 plus n, which is 9, minus 1 times D, which is 14. So that's going to be 118 is equal to a sub 1 plus 8 times 14. The 8 times 14 gives us 112. So that's 118 is equal to a sub 1 plus 112. Subtract the 112 from both sides. You have that a sub 1 is equal to 6. So to find the 432nd term, we're going to find a sub 432 is equal to a sub 1, which is 6, plus n, which is 432, minus 1 times d, which is 14. So it's going to give us a sub 432 is equal to 6 plus 431 times 14. The 431 times 14 gives us, or simplifies this to be a sub 432 is equal to 6 plus 6,034, which gives us the 432nd term as 6,040.